So in previous lecture we discussed about some example and some cases and some correction. Clear? So in this lecture, we threw out the two example of different methods. So this is combinations of first and second case, sorry, second and third case, and the third one, third example to calculate thickness of different point. So second example, the floor is given which is 50 meter and two lines of cutoff which is 80 meter. Clear? So means two pile is given at both sides, and the thickness for upstream which is 2 meter, sorry 1 meter, and for downstream which is 2 meter. Clear? So the head which is 5 meter over the weir and calculate the uplift pressure to inside two corner points. So the corner point C and E. The data is like that: B is equals to 50, H equals to 5, D1 and D2 which is same 8 meter. So first case, in this example, we calculate from downstream side. Otherwise, you can consider upstream side. There are no issue. So for downstream side, the formula, first of all, we find out alpha. Alpha, what is mean alpha? Which is constant equals to B by D. So what is the B? B is equals to 50. And what is the D? Which is 8. Clear? 8 for downstream pile. Then like the example is like given for upstream pile length which is 4 meter, and for the downstream length which is a 8 meter. Clear? So 8 meter which is a D1, and when you calculate for upstream section, so D which is equals to 4 meter. Clear? Please remember that. And you know that the formula for a lambda which is 1 plus under root 1 plus alpha square divided by 2. So you have alpha, so we will put this value in this equation, so we get lambda. Again, there are in downstream section there are 2 points, phi E and phi D. Clear? And what is the meaning of phi C? Phi C equals to 0. So in this section we find out 2 point phi E and phi D. So what is the value of phi E? 1 upon pi cos inverse 2, sorry, lambda minus 2 divided by lambda. So we have the value of lambda. So why can you wait? Then put this value of lambda in this equation. Clear? So we get in decimal form 0.3499. So we will convert into percentage form, that called 34.99 percentage. Same as for which point? Phi D. But what is the formula for phi D? 1 upon pi cos inverse lambda minus 1 divided by lambda. Clear? So we get 0.2409. So again we convert into percentage form, 24.09 percentage. So we have the two constant phi E and phi D. So what is the next procedure? So the next procedure is to calculate thickness or correction. Clear? So first correction due to thickness, the flow goes to E to D section. Clear? And you know that for downstream section the correction is minus or subtractive form. So phi E minus phi D divided by D into T. So we have thickness of downstream flow 2, and we have phi and phi D in percentage form. Clear? Please remember that the value is put in this percentage form. 34.99 minus 24.09 divided by 8 multiplied. So we get minus 2.73%. Next correction due to interference of upstream cutoff. The formula is same, 19 under root D by B dash, small d plus capital D divided by B. So in this section, small d and capital D obviously same, but when the depth of pi which is 8 meter and for downstream section, and the depth of pi for upstream section is 4 meter. So the capital D is equals to 8 and the small d is equals to 4. Clear? When you consider or when you calculate upstream or downstream section, like downstream section, the downstream depth of pile which is a capital D. Clear? And another one is small d. So we have all the value put in this equation. In this equation, or which is B or B dash C, because there are no intermediate pile is provided. So the B and B dash is C. So we get minus 2.43. Again, you know that the correction for downstream side, which is subtractive form, and for upstream section, which is a positive or additive form. Clear? So we have the phi E constant, which is 34.99. So we have two correction. So phi E minus correction due to thickness minus correction due to interference, like this. So we get final corrected phi E is equals to 29.83. Done. And how can you calculate uplift pressure? So the formula is PE is equals to phi E into H. What is H? Means head. So we get 1.49 meter. Done. So this is a case of downstream section. Same as for upstream cutoff. Same as alpha equals to B by D1. Lambda same. But the formula is changed like this. In downstream section, there are lambda minus 2. But in upstream, 2 minus lambda. Clear? So we have all the value. Put this all these value in this equation. So we get phi C and same to same phi D. So we get 65 and 75. Again, correction due to thickness. In this upstream section, the flows go to D to C. So phi D minus phi C divide into T divided by D. Clear? So there are some mistakes. There are no subtractive form. There are additive form. Here, please do not consider the minus sign. So correction due to thickness, we have phi D and phi C, which is phi D 75 and phi C 65. So we get 1.36 percentage. Same as the formula correction due to interference pile, 2.43 percentage. So in upstream side, correction which is additive form. So 65, which is phi C plus correction due to thickness plus correction due to interference. So we get 65.01 plus 1.36 plus 2.43, which is 68.8. The next one, P. How can you calculate P is equals to phi E into H? We get 0.688 into 5, which is 3.44 meter. This is your final answer for upstream section, or this is the final answer or for uplift pressure at the point, and this is your final answer at downstream point. Clear? And how can you calculate exit gradient? So G is equals to H by D 1 upon pi under root lambda. So how can you add? Lambda means lambda for downstream section. So we get G. Clear? Next formula is, sorry, the next example is calculate thickness. Clear? So in this example, you calculate thickness at different point. Done? So Blick-Crib theory, calculate thickness of downstream floor at every 5 meters. Means at a downstream floor, you can calculate thickness at every 5 meters. Means different point. And also check the whether flow length is sufficient or not. And the data is given like length of upstream floor, which is B1. Clear? This is the upstream portion. And this is your downstream portion. And this is H equals to head on downstream side, which is 0. Depth of upstream pile, which is 5 meters, means D for, and same depth for downstream pile 6 meters. And Blick-Crib coefficient is equals to 8. And last one, weight density of concrete, which is 24. Here, so creep length. You know that what is the meaning of creep length? Means the path traveled by the water, that called creep. So just a minute, I will show by the highlight like this. Here, so the water goes like this to this direction, and move to horizontal direction till downstream pile, again water goes to this direction. So what is the length of the particular of crepe line? So again, so this is the H. Here, so this is a 2 times multiply by D, so that called 2 into D. This is a 2 into D. Here, then again the upstream flow length. So what is the upstream flow length? This is equals to 20. So this is a 20. Then this is a 20, and again the downstream length. This is a 30. Here, this is a 30, and again the water goes to downstream pile and like this. So multiply 2 into D. This is a 2 into 6. So the total length, which is a 72 meter. So what is the meaning of hydraulic gradient? So hydraulic gradient means head loss per unit length. That called H by L. So what is the H? H equals to 4 meters. So 4 by 72, which is equals to 1 by 18. The next one, specific gravity. So how can you find a specific gravity? So the 2.4 is given, specific gravity, which is 2.4 divided by 9.8. So we get 2.44. Otherwise, you remember that the specific gravity of concrete, which is 2.44. And this is a formula to find out uplift pressure, again H minus I into L. Clear? Remember this formula, P is equals to H minus I into L. Clear? So this is a very important formula to find out thickness at different length. Again, so first of all, we calculate uplift pressure at the 5 meter from B. Means, so this is called B point. This is called B point. Done. At that point, we calculate downstream floor thickness at every 5 meters. So from B point, so what is the formula? P is equals to H minus I into L. Clear? So what is the H? H equals to 4. What is I? I is equals to 1 by 18, as you know. So in this section, we calculate different length or different thickness at every 5 meter from downstream section. So what is the basic formula? P equals to H minus I into L. Clear? H minus I into L. So H is the, at every point H is common and I also is common. So what is the change? Change in land, change in creep land. Clear? So first of all, first at downstream side at 5 meters. So the water goes like this from this to or this is like up to 5 meter. Done. So what is the total land? The water travels 2 times multiply depth of upstream pile, then plus length of upstream flow plus 5. This is a creep length. Clear? So this is a creep length. So you can easily calculate P5, that equals to 2.05. And what is the thickness formula? You know that 4 by 3 H upon G minus 1. And what is the H? H means P5. So putting this equation, so we can get P5. Clear? Again, uplift pressure at the, again 10 meter from B. So it's the simple like this. There are additional of 5 meter distance. So like this. So total distance 10 plus 20 plus 10 is equals to 30. Like this, this is your creep length. Done. So P10 is equals to 1.77. Put in this equation in P10. So you get T10, same as for 15 meter. So the creep length change, which is additional plus 50. Fourth one same, fifth one at 25, sixth one at 30. Till the 30 meter, till that 30 meter you can calculate, or you should calculate at 30 meter. And if the 40 meter length is given of downstream side, so again there are two steps is coming: uplift pressure at 35 meter from B, 7 uplift pressure at 40 meter from B. Clear? So you can easily calculate by these two formula: P equals to H minus I into L and T is equals to 4 by 3 H upon G minus 1. Done. But in this case, the flow length is given, which is proper or not. So how can you calculate? Clear? So the length is equals to 70, head is equals to 4. You know that 4 by 70, that hydraulic gradient, and Blick coefficient is given 0.055. Clear? So which is near about safe. There are no case in undermining or pipe. Clear? So there are three main basic example of their fourth chapter. Clear? So there are some formula which will remember. Clear? For their two cases very important, upstream side and downstream side, and there are thickness formula. Clear? Thank you. Thank you for attention.